Okay, in this video, we're going to go over a related rates problem. So we have Annabeth, who's driving to work, 45 miles to work as her commute. If she increases her average speed by 5 miles an hour, the time it takes her to drive to work is decreased by 6 minutes. Find her usual average speed. And so first step is identifying that this is a related rates problem. All right, I know this because it's discussing rates, the rate that she's driving to and from work. It gives us ways to relate them. It gives us like, all right, one speed is 5 miles more than the other. All right, it also references time and distance. All right, the next step is to, come to familiarize yourself with this formula. Distance equals rate times time. All right, so it's something that you've known for a while. If you made it this far in math, all right, distance is equal to rate times time. Let's say you jog 8 miles an hour. That's pretty fast. Let's say you jog 5 miles an hour for 3 hours. All right, that's 15 miles. 5 miles an hour times 3 hours, 15 miles. All right, same concept. So the next step that I like to do is make a table. So I go distance, rate, and time, and that gives us 3 columns. And then and then we have 2 rows, and each row is going to be represent a different thing that's moving. All right, or yeah. So in both cases, it's Annabeth driving to work. All right, so it says she drives. Well, before we read the question again, just some rule of thumb here. So when you set up this table, you're usually going to be given like one of these variables. So like you'll know the 2 times, and then you'll be given enough information to come up with variables or expressions for the other 2. All right, so distance, rate, and time, there should always be only 2 unknowns. And then it turns into solving a system, which we can do with our calculator. But one of these, distance, rate, or time, you'll be given. All right, so it says she drives 45 miles to work. All right, she increases her speed, and then her time gets decreased. So that overall like structure of the question tells us what our 2 relationships are. One of them is Annabeth driving to work like her usual speed, and the other one is when she drives to work her fast speed. All right, now the variable that we're given here were the distances, because it says she drives 45 miles to work no matter what. Sometimes she drives faster, sometimes she drives slower, but her distance is always going to be 45 miles. And it's important to indicate the units. So distance is going to be in miles, which means rate has to be in miles per something, probably hour. So then it says her speed, um, she increases her speed by 5 miles an hour. So if her usual speed, if we call that R, her fast speed is going to be R plus 5. And since 5 is 5 miles an hour, our rate is now going to be in miles per hour because we want these to be in the same units, which means our time has to be in hours. All right. And that's very important. That is a common place where people mess up. So it says the time it takes her to drive to work is decreased by 6 minutes when she increases her speed. So if we let t be the usual amount of time it takes her to drive to work when she drives her usual speed, then t minus 6 minutes will be her fast speed. Now we're subtracting because we're going faster, the same distance, right? So if I said walk from here to the end of your room, and I said sprint from here to the end of your room, if it's the same distance both times, the time it would take you to travel would go down because you're moving faster. Right, but we don't want to do t minus 6 because 6 is minutes and our time is in hours. So instead, we're going to do minus 6 over 60, which is the same thing as t minus 1/10. All right, because 6 minutes is 1/10 of an hour. Okay, so now we have our equations. We have distance equals rate times time. So 45 equals r times t. 45 equals r plus 5 times t minus 1/10. So now we're going to type that in our calculator. So I'm going to place this right here so I can reference it when I type it in the calculator. And I'm going to go to my home screen, type in a new doc, add a calculator, menu, algebra, solve system of equations, not linear equations because these are regular equations. All right, now I can make my variables r and t for rate and time. Now I'm going to type it in. So My first equation is going to be 45 equals r times t. My second equation is going to be 45 equals parentheses r plus 5 times close parentheses times t minus 1/10. And then hit enter. And we have our answers. We got -50 and -9/10. All right, that's very common because since these aren't linear equations, if you were to isolate a variable and solve with substitution, you would get a quadratic. So that makes sense that they intersect at 2 points. But in the context of the problem, you have to keep in mind domain. All right, R is a rate, so rates have to be positive. All right, and time is if t equals 0 is well, if time is the in terms of how long it takes her to get to work, that can't be negative either. So we're going to go with the second answer where t is 1 hour and r is 45 miles per hour. And if you plug that in, everything else checks out. So find her usual average speed. It's going to be 45 miles an hour.